Hello students, welcome to my YouTube channel Integrated Physics Studies IPS. एथिरे मु ऑलरेडी प्लस टू सेकेंड इयर सिलेबस कंप्लीट कर सारी एवं मु प्लस थ्री सीबीसीएस फिजिक्स ऑनर्स जीई आ एमएससी फिजिक्स ऑनलाइन क्लासेस रो वीडियोस अपलोड करुच्ची जदि भल लगिला ताले वीडियोस को लाइक करदेव और चैनल को सब्सक्राइब करदेव यू कैन शेयर इट विथ योर फ्रेंड्स ऑल्सो इट्स कम्प्लीटली फ्री ऑफ कॉस्ट लेटेस्ट वीडियो नोटिफिकेशन बेल आइकन को ये ऑल सेट करदेव तापर वीडियोज क्लारिटी बढ़ाई गो टू सेटिंग्स क्वालिटी एडवांस उपरे क्लिक करी यू कैन इंक्रीज द रिजोल्यूशन सबू वीडियोज पीडीएफ नोट्स मु पठेबी जोटा एठी ड्रॉप डाउन लिस्ट को क्लिक करी यू कैन गेट द लिंक फ्रॉम द डिस्क्रिप्शन बॉक्स तापरे मोर चैनल नेम को क्लिक कले सबू वीडियोज को मु यूनिट वाइज एच पार सिलेबस सजाई की रखिथिबी व्हिच यू कैन गेट फ्रॉम द प्लेलिस्ट एठी सर्च करि परिबो ओके थैंक यू हेलो स्टूडेंट्स आज टॉपिक रे हमें द थ्योरी ऑफ व्हाइट ड्वार्फ स्टार्स ए विषय में पढ़ा ता सहित एट द एंड आम देखा व्हाट इज द चंद्रशेखर्स लिमिट। तो देख फास्ट एक्चुअली आम गोटे जदि ब्राइटनेस देखा गोटे स्टार रो ओके गोटे तारार ब्राइटनेस जदि देखा इट इज एन एम्पिरिकल रूल ओके। तो ये ब्राइटनेस एम्पिरिकली इट इज प्रोपोर्शनल टू इट्स कलर ओके मतलब the predominant wavelength which is emitted by the star. Now this proportionality constant is roughly the same for all the stars. Okay, सबु प्रकार स्टार पाई proportionality constant roughly समान रही था. Thus if we make a plot of this brightness against the color then we will obtain a graph जहाँ को की कहा जाए in the name of scientist Hertzsprung-Russell diagram. Okay, in which most stars fall within a linear strip which is called as the main sequence. Okay, so a graph को आमे जदि देखिबा this is shown in the figure here. Okay, you can see here brightness is taken along the y-axis and the color is taken along the x-axis. Okay, color is going from white to red, right? So white जो color टा रोची एटा white dwarf पाई ओके आउ रेड आड़ को गले आमे रेड जाइंट आड़ को जीबा ओके एटा आछि तमरो जो मेन सीक्वेंस टा ओके याकू कहा जाए रसेल हर्ट्जस्प्रंग डायग्राम और हर्ट्जस्प्रंग रसेल डायग्राम ओके। अच्छा so there are however stars which you can see they are actually the exception to this rule okay ei rule ru bi exception रे थिबा किछिटा स्टार रोची and there are red giants okay जो red giant stars रोची which are actually huge in size okay and abnormally bright for their red color okay that's why याको red giant बोली कि कहा जाए and there are also white dwarf माने एठी जणा पड़छि जे ए स्टार रो साइज टा बहुत कम थिबो छोटो साइज रो रही थिबो okay they are the small stars which are abnormally faint for their white color okay. So the white dwarf star makes an interesting subject for our study because to a good approximation it is a degenerate Fermi gas type okay याको हमें degenerate Fermi gas सहित कंपेयर करि परिबा okay. So a detailed study of the constitution of this white dwarf stars will lead us to the conclusion that they lack the brightness. Why? Because the hydrogen supply, which is the main source of their energy, has been used up okay and they are composed of mainly helium okay. So what little brightness that they have is derived from the gravitational energy which is released through the slow contraction of the star okay. So that contract होता है a star टा okay. So probably these stars have reached the end point of stellar evolution okay. So एमाने तांकर माने end point बा मृतप्राय हो जाइथांती स्टेलर इवोल्यूशन जेतले हेइतिला एमानकर. So one of the nearest star to our solar system is the companion of Sirius okay or Sirius okay and 8 light years away this star is away from us okay. It is a white dwarf. Now it is so faint that it escapes the naked eye खाली आखिरा हमें याको देखी परिबा नहीं यार माने फेंट जेहेतु रोची यार कलरटा ओके एंड इट वाज फर्स्ट प्रेडिक्टेड by means of calculation of Bessel, who tried to explain why Sirius apparently moves about a point in empty space. Okay, so याको एबे आइडियलाइज्ड करबा पई हमें गोटे मॉडल रखिबा व्हाइट ड्वार्फ रो okay which can be constructed from some typical data of such a star like what hela content as we have discussed it is containing mostly helium density are nearly 10 to the power 7 gram per centimeter cube रहुची माने it is nearly equal to 10 to the power 7 times of rho 0 rho एठी जो 0 बा o लेखा होची एटा डिनोट करा जाउची और रेफर करा जाउची as compared to our sun ओके सो सूर्य रो डेंसिटी रो 10 टू द पावर 7 टाइम्स माने 1 कोटी गुणा रहुची राइट अच्छा तापर जदि देखिबा मास यार 10 to the power 33 gram रहुची which is nearly equal to the mass of the sun and the central temperature is 10 to the power 7 Kelvin which is also nearly equal to the temperature of sun ओके सो एठी ये जो ओ सिंबल और ये जो एमती ओ करिकी मझिरे डॉट दिया जाउची it denotes the quantities referring to our sun okay thus a white dwarf star is a mass of helium at an extremely high temperature under extreme compression okay माने बहुत हाई प्रेशर भी अच्छी so a temperature टा 10 to the power 7 Kelvin रहुची which is corresponding to a thermal energy of 1000 electron volt hence the helium atoms are expected to be completely ionized at this energy at this temperature okay so the star may be regarded as a gas which is composed of helium nuclei and electrons okay so এই বেসিসରେ ଆମେ ୟାକୁ ଗୋଟେ ଫର୍ମି ଗ୍ୟାସ୍ ସହିତ ତୁଳନା କରିପାରିବା so we regard the gas of electron as an ideal Fermi gas because ଆମେ ଜାଣିଛୁ electron ହଉଛି ଗୋଟେ fermion okay so ଏଠି ଆମେ ୟାକୁ ideal Fermi gas ସହିତ compare କରିପାରିବା having a density approximately equal to 10 to the power 30 electrons per centimeter cube right and this corresponds to a Fermi energy of around EF which is equal to h cross square by 2m 1 by v to the power 2 by 3 which is nearly equal to 20 MeV and a Fermi temperature around 10 to the power 11 Kelvin. Now since the Fermi temperature is much greater than the temperature of the star so the electron gas is a highly degenerate Fermi gas okay so Fermi temperature जदि आमे देखिबा एटा आछी केते 10 to the power 11 Kelvin आ टेम्परेचर और स्टार जो रही सेटा 10 to the power 7 Kelvin माने 10,000 गुणा अधिका आछी तेणु करी इलेक्ट्रॉन गैस को हमें हाईली डिजेनरेट बोली की कहि परिबा फर्मी गैस भलिया which behaves no differently from an electron gas at absolute zero okay and in fact we regard or we consider the electron gas to be an ideal Fermi gas in its ground state okay and the enormous 0 point pressure which is exerted by the electron gas is counteracted by the gravitational attraction hochi it is responsible for binding the star okay and this gravitational binding is due to almost entirely all helium nuclei which is contained in the star okay so the pressure due to the kinetic motion of the helium nuclei and to any radiation that may be present will be neglected okay एठी हमें प्रेशर को काइनेटिक मोशन द्वारा जो हीलियम न्यूक्लियर आछी ताको हमें नेग्लेक्ट करि परिबा जे कोनोसी भी रेडिएशन रो सेटा बाहरुची okay thus we arrive at the following idealized model कोन सेटा a white dwarf is taken to be a system of Fermi gas which is containing n electron in its ground state at such a density that the electrons must be treated by relativistic dynamics okay एठी हमें relativistic approach नमा classical नुहो okay and the electrons move in a background of n by 2 motionless helium nuclei which provide the gravitational attraction to hold the entire system together. Okay, ଏଠି ଗୋଟେ ଦେଖ ଷ୍ଟାର ମାର୍କ କରିଲା। Okay, ଷ୍ଟାର ମାର୍କ ମାନେ ୟାକୁ ବୁଝାଉଛି ଇଏ ତଳେ ଏଠି ଦେଇଛି। what is this? ଦେଖ ଷ୍ଟାର ମାର୍କରେ କହୁଛି the temperature is an actual white dwarf star जोटा रहुची it is so high that electron positron pair can be created in electron electron collision. Okay, and these pair in turn annihilate into radiation. Therefore, in equilibrium there should be a certain number of electron positron pair and a certain amount of radiant pressure. Okay, so we neglect the effect of these pressure, and it has been speculated that neutrinos can also be created in electron electron or electron positron or photon photon collision, which actually having appreciable probability. Okay, so this leads to some interesting phenomena for neutrinos, which are interacting so weakly with matter that they do not come to thermal equilibrium with the rest of the system. Okay, and they simply leave the star kid, cause a constant drain of energy. Okay, এটা ବାହାରି ଥିଲା ଗୋଟେ ଜର୍ନାଲରୁ, ସେଇ ଜର୍ନାଲରୁ ୟାକୁ କୋଟ୍ କରାଯାଇଛି। and our model is based on the neglect of these effects. Okay, so ଏଇ ସବୁ ଇଫେକ୍ଟକୁ ନେଗ୍ଲେକ୍ଟ କରିକି ଆମେ ୟାକୁ ବାହାର କରିବା। so this model must then exhibit the properties that are actually combined effects of Pauli principle, because ଜାଣିଛ ତମେ ଫର୍ମିଅନ୍ ବା ଫର୍ମି ଗ୍ୟାସ୍ ପାଉଲି ଏକ୍ସକ୍ଲୁଜନ ପ୍ରିନ୍ସିପଲକୁ ଓବେ କରିଥାଏ। and also ଏଠି ଆମେ ରିଲେଟିଭିଷ୍ଟିକ୍ ଡାଇନାମିକ୍ସକୁ ୟୁଜ୍ କରିବା, ଆଉ ଅଲସୋ ଗ୍ରାଭିଟେସନାଲ ଲକୁ ବି ଆମେ ୟୁଜ୍ କରିବା। ଫାର୍ଷ୍ଟ ଆମେ କ'ଣ କରିବା, let us work out for the pressure which is exerted by a Fermi gas in the relativistic electrons in the ground state. So the state for a single electron which are specified by momentum धर ହେଲା ଏଠି p, spin quantum number, because ଜାଣିଛ इलेक्ट्रॉन होची गोटे हाफ इंटीग्रल स्पिन वाला पार्टिकल, सो स्पिन क्वांटम नंबर s को हमें प्लस और माइनस हाफ नहीं परिबा। so the single particle energy levels are independent of this spin s, so आको हमें लिखि परिबा relativistic energy EPS equal to square root of p square c square by p0 whole square plus me square c4 or me c square रो whole square. Okay, so एठी me हला mass of the electron, आउ ground state energy Fermi gas रो आमे बाहर करि परिबा E0 is equal to 2 times, okay, 2 times of summation mod p less than pf. okay, एई वैल्यू जोटा EPS पाइथला ताको पुट कर देला। okay, so ए समेशन को हमें इंटीग्रेशन रे रिप्लेस कर दबा जदी 0 to pf यार लिमिट्स आसीबो। ओके, आउ ए जो इंटीग्रेशन रे फैक्टर हमरो जो 4 पाई p स्क्वायर dp एटा मोमेंटम जो दुईटा स्फीयर रोची गोटे विथ रेडियस p आ गोटे स्फीयर विथ रेडियस p प्लस dp। ओके, सो ए जो पार्ट एनुलर पार्टटा तार वॉल्यूम एठी लिखिछि 4 पाई p स्क्वायर dp। ओके, ऑलरेडी एटा तमे डेराइव करि सारिछो। ओके, so here pf is the Fermi momentum which is defined by v by h cube 4 by 3 pi pf cube which is equal to n by 2। okay, ताले एठी pf को हमें लिखि परिबा h cross 3 pi square by small v to the power 1 by 3। okay, so एठी देखो आमे चेंज करिबा जदी वेरिएबल ए इंटीग्रेशन रो, ताले x को आमे लिखि परिबा इक्वल टू p by mec। ओके, p by mec जदी आमे लिखि दला ताले we can obtain E0 by capital N to be equal to me4 c5 by pi square h cross cube v into f of xf। ओके, एटा सॉल्यूशन करला परे ए रिप्लेसमेंटटा आसीची। ओके, एठी डायरेक्ट एठी लिखि दिछि ए जिंसटा। ओके, सो एठी देखो ऊपर मार्क करो जो हमरो रिप्लेसमेंट आसीची, रिप्लेसमेंट ए थ्रू ए जगारू प्रथमे बाहर करा गला कोन pf रो वैल्यू। एठी देखो स्मॉल v जोटा दउची this is nothing but v by n, okay, small v। ଆଉ h cross तो ତମେ ଜାଣିଛ already, ଏଟା ହେଉଛି h by 2 pi, okay। so pf cube को ଏଠିରୁ ବାହାର କର ଫାଷ୍ଟ, ତାପରେ pf को ବାହାର କରିପାରିବା ଆମେ, ଏତିକି ଆସିବ, okay। ଆଉ ରିପ୍ଲେସମେଣ୍ଟ କରିବା କେଉଁ ଜାଗାରେ, ଏଇ ଯେଉଁ ଇଣ୍ଟିଗ୍ରେସନରେ ବାଇ ପୁଟିଂ x ଗୋଟେ ନୂଆ ଭେରିଏବୁଲ ଆମେ ନେଉଛୁ, ଯେଉଁଟାକି ତାର ଭ୍ୟାଲୁ ଏଠି କହୁଛି p by mec, ओके। रिप्लेसमेंट करिकी इंटीग्रेशन भितर जो भी भैल्यूटा आसूची ताको एज ए फंक्शन ऑफ xf आमे धरिबा, ओके। सो व्हाट इज this function of xf is equal to the integration 0 to xf dx x square then into square root of 1 plus x square एतिकी आसीबो। आ यार दुईटा वैल्यू आसीबो, काहे दुईटा वैल्यू, depending upon the value of xf whether it is very less than 1 or very greater than 1, okay। गोटे आछी 1 by 3 xf cube, then it is multiplied with 1 plus 3 by 10 xf square plus the higher order terms। आ गोटे आछी 1 by 4 xf4 into 1 plus xf square plus the higher order terms, okay। so आमे रिप्लेसमेंट नहीं थिला x equal to p by mec, okay। सिमिलरली xf को आमे लिखि परिबा pf by mec, और एठी आमे pf रो जो वैल्यूटा पाइथिला ताकू जदि पुट कर दबा we will get a result like this। so if the total mass of the star is capital M and the radius of the star is capital R, ताहले आमे लिखि परिबा केमथि capital M to be equal to, you can see me, which is the mass of the electron, plus 2 times of mp, which is the mass of the proton, into capital N, or it is nearly equal to 2 mpn, because we can neglect the mass of electron as compared to proton mass, because electron mass टा 10 to the power minus 31 kg रे आसे, आ proton mass टा 10 to the power minus 27 kg रे आसे। सो इलेक्ट्रॉन मास को हमें प्रोटॉन मास रो कंपैरिजन रे नेग्लेक्ट कर देला, नियरली इक्वल टू 2 mpn बोली कि लिखिला। आउ जो रेडियस कथा कहूची, रेडियस को हमें लिखि परिबा 3v by 4 pi to the power 1 by 3। एटा केमती आसिला, v जदि हे गला वॉल्यूम ताले हमें जानिचो v इक्वल टू 4 by 3 pi r क्यूब हुए। सो यही जगार r रो वैल्यूटा एमती आछि, ओके। अच्छा, now in terms of m and r we have that v माने capital V by n, okay। it is one kind of your density, okay, number density। so this is equal to, by putting the values, how much, 8 pi by 3, okay, into mpr cube by capital M, ओके। यही वैल्यू आमे पाउचु कहार v रो। आ सिमिलरली एबे xf जोटा ऊपर आमे पाइथिला एही जगह रे, ओके, एठी एबे v रो वैल्यू जदि आमे पुट कर दबा, राइट, देन वी विल गेट अ वैल्यू लाइक दिस। एठी आमे रिप्लेसमेंट आनुचु m bar to the power 1 by 3 divided by r bar, ओके। एठी m bar माने कोन आ r bar माने कोन, देखो m bar वैल्यू से दउची 9 pi by 8 m by mp, और r bar वैल्यू दउची r by h cross by mec, okay। now the pressure which is exerted by the Fermi gas, okay। so एठी p0 याको आमे लिखिबा, its value will be equal to minus del E0 by del V। एटा केमती आसिला, एटा फर्स्ट लॉ ऑफ थर्मोडायनामिक्स को मने पका, तमरो आसी थाए dq is equal to du or de plus pdv, राइट। अच्छा, जदि आमे एठी गोटे एडियाबेटिक प्रोसेस नहीं जाउछु ताले dq रो वैल्यू आसी जिवो 0, और एठी आमे पाइबा कोन d plus pdv equal to 0 और p equal to minus of d by dv, ओके। से जिनस को ए हिसाब रे ये लिखिछि, ओके। ताले एबे आमे यार वैल्यू बाहर करिबा जदि then it will be like this. ଏଠି ଉପରେ ଦେଖ ଆମେ already ପାଇଥିଲା value, okay, this one e0 by n ଏଇ ଜାଗାରେ e0 ର ଭ୍ୟାଲୁଟା ଅଛି, ଓକେ, ତାକୁ ନେଇକି ବସେଇବା କେଉଁ ଜାଗାରେ, ଯେଉଁ ଡିଫରେନ୍ସିଏସନ୍ ହେଉଛି, ଓକେ, ତାହେଲେ accordingly यार वैल्यू आसची me4c5 by pi square h cross cube into minus fxf minus del f xf by del xf into v del xf by del v, ओके, ताले या को एबे जदि टिके आमे सॉल्व कर दबा, देन यार वैल्यू आसीबो, एटा तो एज इट इज रहउची 1/3 xf cube into square root of 1 plus xf square minus fxf, ओके, सो एठी डिफरेंशिएशन कला परे एति कि यार वैल्यू आसुची, ओके, एबे यार ग्राफ जदि आमे देखिबा ताले देखो नॉन रिलेटिविस्टिक एप्रोक्सीमेशन जदि आमे नउचु ताले p0 अगेंस्ट रे रेडियस r को जदि पुट करिबा ताले नॉन रिलेटिविस्टिकली यार ग्राफटा ए टाइप रो आसीबो, ओके, माने এই জায়গায় এক্সট্রিম রিলেটিভিস্টিক লিমিট আর নন রিলেটিভিস্টিক লিমিট আমি দেখিবা, ওকে, ফর द केस ऑफ p0 तो फर्स्ट नॉन रिलेटिविस्टिकली जोटा ग्राफ ऊपर आम देखुचु p0 रो वैल्यू आसी जाउची फॉर xf वेरी वेरी लेस देन 1, ओके, xf टू द पावर 5 हे जाउची एठी, ओके, बाहर एठी जो क्वांटिटी रहउची, सो याको आम रिप्लेस कर दी परिबा 4/3k into m bar to the power 5 by 3 by r bar to the power 5, okay, तापरे extremely relativistic case where xf is very very greater than 1 ताहले देखो एबे ई क्वांटिटी रे आसची xf4 minus xf square, ओके, ताहले एठी बाहर रहउची क्वांटिटी हमरो me4c5 by 12 pi square h cross cube, okay, that means याको आम लिखिपर k इंटू आमर जो सब्स्टिट्यूशन करदेबा एक्स एफ को इन टर्म्स ऑफ एम बार और आर बार को लिखिदेबा ताले एम बार टू द पावर 4/3 बाय आर बार टू द पावर 4 माइनस एम बार टू द पावर 2/3 बाय आर बार टू द पावर 2, ओके, एठी रिप्लेसमेंट आम जो आनी थिला k यार वैल्यू होउची दिस मच, ओके, राइट, सो this is the value of k and a qualitative plot एबे जदि देखिबा p0 रो अगेंस्ट r for fixed m, okay, m रो वैल्यू जदि फिक्स्ड रहउची it is already shown in the figure this one, okay, एटा नॉन रिलेटिविस्टिक पाई, राइट, जोटा हमरो डॉटेड लाइन हमरो ए नॉन रिलेटिविस्टिक को शो करूची, ओके, अच्छा, so it is seen that for small r यदि रेडियस स्टार रो बहुत छोटो रहउची then p0 becomes smaller than what is expected on the basis of non-relativistic dynamics. So the condition for equilibrium of the star may be obtained. Equilibrium condition केमती आमे बाहर करिबा by using the following argument. आमे कौन करिबा, we will imagine that there is no gravitational interaction, then density of the system will be uniform, ओके, किसी भी जदि ग्राविटेशनल इंटरैक्शन नाही पार्टिकल भितरे ताले यूनिफॉर्म डेंसिटी रे समाने रहउचंती and the external walls will be needed to keep the Fermi gas at a given density, okay, बाहरु किछि हमको external walls रो दरकार पड़िबो, so the amount of work that an external agent has to do to compress this star of given mass from a state of infinite diluteness, infinity ru आनिबा हमें सब ये जो particle को to a state of finite density, it will be given by minus of integration infinity to r p0 4 pi r square dr, p0 हेगला एठी तमरो जो pressure of a uniform Fermi gas r होची radius. Now imagine that gravitational interaction is switched on, एबे gravitational interaction जदि आसी गला ताले different parts of the star will now attract one another resulting in एबे कोन हबो decrease हबो को जिनसरो एनर्जी रो, ओके, so energy of the star will decrease by an amount that is called gravitational self energy. So On dimensional basis or dimensional grounds, the gravitational self energy must be having a form like minus alpha gamma m square by r. এটা এই ଯୋଉ ତମର ନ୍ୟୁଟନ୍ସ ଲ ଅଫ୍ ଗ୍ରାଭିଟେସନ୍ ଟାଇପ୍ର ଗୋଟେ ଏଇଟା ଫର୍ମୁଲା ଆସିଛି ଯୋଉଥିରେ କି ତମେ ଜାଣିଛ ଦୁଇଟା ଯେକୌଣସି ବସ୍ତୁ ତାର ପ୍ରଡକ୍ଟ ଅଫ୍ ଦ ମାସ୍ ଉପରେ ଏଇଟା ଡିପେଣ୍ଡ କରିଥାଏ ଆଉ ଯେଉଁ ଡିଷ୍ଟାନ୍ସ ରହୁଛି ସେଟା ଉପରେ ଇନଭର୍ସଲି ଡିପେଣ୍ଡ କରିଥାଏ। ସୋ ଏଠି ଗାମା ହେଉଛି ଗ୍ରାଭିଟେସନାଲ କନଷ୍ଟାଣ୍ଟ, ଆଲଫା ଇଜ୍ ଏ ପିଓର ନମ୍ବର ଅଫ୍ ଦ ଅର୍ଡର ଅଫ୍ ୟୁନିଟି, ଏଟା ପାଖାପାଖି ନିୟରଲି ଅଫ୍ ଦ ଅର୍ଡର ୟୁନିଟି ରହିଥାଏ। And the exact value of alpha depends on the functional form of the density, which is taken as a function of spatial distance, and it cannot be determined by our argument. Okay, acha jodi r ko dekhiba, if r is the equilibrium radius of the star, then the gravitational self energy must exactly compensate the work done in bringing the star together. ତେଣୁ କରି ଏବେ ୟାକୁ ଆମେ ଦୁଇଟାକୁ ଇକ୍ୱେଟ୍ କରିଦେବା, ମାଇନସ୍ ସାଇନ୍ ଯେଉଁ ଏପଟେ ଥିଲା ଓକେ ତାକୁ ଆମେ ଏପଟକୁ ଆଣି ଆସିଲା ରାଇଟ୍। ଏବେ ୟାକୁ ଡିଫରେନ୍ସିଏଟ୍ କରିବା এই ଇକ୍ୱେସନ୍କୁ ୱିଥ୍ ରେସ୍ପେକ୍ଟ ଟୁ ଆର୍, ତାହେଲେ ଏଇ ଇଣ୍ଟିଗ୍ରେସନ୍ଟା ଯେଉଁ ଥିଲା ଏଇଟା ଉଡ଼ିଯିବ। P0ର ଭ୍ୟାଲୁ ଆମେ ଯଦି ବାହାର କରିବା ତାହେଲେ ଇଟ୍ ୱିଲ୍ ବି ଇକ୍ୱାଲ୍ ଟୁ ଆଲଫା ବାଇ 4 ପାଏ ଗାମା m ସ୍କୋୟାର ବାଏ r ଟୁ ଦି ପାୱାର 4, which is alpha by 4 पाए gamma एठी m रो वैल्यू आमे पुट करूछु 8 mp by 9 पाए रो स्क्वायर आउ also आमे r रो वैल्यू भी पुट करिबा ओके। सो mec by h cross to the power 4 आउ आछि m bar square by r bar 4 okay। so strictly आमे जदि देखिबा 9.55 equation को merely defines alpha and its physical constant is furnished by the assumption that alpha is of the order of unity. So we now determine the relation between m and r. Mass और radius भितर relation आमे बाहर करि परिबा by inserting an appropriate expression for p0 into 9.56, and this will be done for the following three different cases. एटी गोटे जिनस मने रख, मेनली तमरो केस 3 होची बेसी इंपोर्टेंट बा केस सी जोटा फर्स्ट केस जो एठी आमे देखु जो केस 1 by case A, suppose temperature electron gas much higher than the Fermi temperature, then electron gas may be considered as an ideal Boltzmann gas. Okay, माने classical gas बढ़िया टा behave करिवो P0 equal to KT by V ही जिवो और एठी आमे V रो वैल्यू को हिसाब रे पुट कर देले सब्स्टिट्यूट कर दबा जदी पुनी P0 रो वैल्यू ताले R रो वैल्यू आमे पाई परिबा like this. Okay, and this case however is never applicable for a white dwarf star. Okay, so it fail hela tapare case 2 or case B, suppose the electron gas is at such a low density that non-relativistic dynamics may be used, mane xf is very less than 1, then p0 given by 9.50 and 9.56 leads to equilibrium condition. Okay, so 4 by 3 k m bar to the power 5 by 3 by r bar to the power 5 is equal to k dash. Okay, it out a constant aschi jar value this much okay into m bar square by r bar to the power 4. Okay, so a through aschi radius star ro ame as compared to the mass yaku lekhi pariba which is increasing like m bar to the power 1 by 3 r bar is equal to 4 by 3 k by k dash. However, this condition is valid when the density is low, hence it is valid for small mass and large radius. एबे जोटा कहउतली important case होची तमरो extreme relativistic case जोटा suppose electron gas is at such a high density okay पूरा high density रे अछि that relativistic effects are now important. Okay, that means xf is very greater than 1, then p0 as given by 9.51 याको एबे हम अप्लाई करिबा and the equilibrium condition now becomes k into m bar to the power 4 by 3 by r bar to the power 4 minus m bar to the power 2 by 3 by r bar to the power 2 to be equal to k dash m bar to the power square by r bar to the power 4. एई थ्रू एबे हमें सॉल्व करि परिबा r bar रो वैल्यू हमें काढी परिबा केमती सॉल्व करिबा देखो एडी गुडे जिनस मार्क करो this equation here okay एठी r bar जोटा अछि okay r bar to the power 4 गुटे रे अछि एठी भी अच्छी r bar to the power 4 can be taken common, right? आ गुटे term अच्छी r bar to the power square. So it is some kind of a quadratic equation जो थिरे तमे लेखो ax square plus bx plus c is equal to 0, and here in this case x is replaced with 1 by r bar to the power square. ओके यही हिसाब रे x रो रिप्लेसमेंट नियो आ c एई केस रे 0 ही अछि. ओके सो यार वैल्यू x रो वैल्यू दैट इज 1 by r bar square रो वैल्यू केते हेबो ना माइनस b प्लस और माइनस b स्क्वायर माइनस योर 4ac डिवाइडेड बाय 2a. एई फार्मूला तो तमे स्कूल टाइम रो जानिचो ताकू अप्लाई करी कि याकू हमें एबे r bar रो वैल्यू एति की बाहर करी परिबा. ओके सो इट इज m bar to the power 2 by 3 into square root of 1 minus m bar by m bar 0 to the power 2 by 3. So एटी गोटे क्वांटिटी आछि m bar 0. Okay, m bar 0 माने कोन? It is the ratio of k by k dash to the power 3 by 2. Okay, this one, and it is equal to 27 pi by 64 alpha to the power 3 by 2 into h cross c by gamma mp square to the power 3 by 2. ओके आ जदि न्यूमेरिकल कैलकुलेशन करूछु हमें ताले h cross c by gamma mp square रो वैल्यू नियरली equal to 10 to the power 39 आसीबो, and this interesting pure number is nothing but the rest energy of x divided by the gravitational attraction of the two protons which are separated by the Compton wavelength of x, where x is anything. Okay, ଯେକୌଣସି ଜିନିଷ ବି ହେଇପାରେ. So the mass m0 here corresponding to the reduced quantity m0 bar, and ଯଦି ଆମେ ଏଠି alpha କୁ nearly equal to 1 ନେଇଯିବା ତାହେଲେ m0 ର value ହେଇଯିବ କେତେ ନା 8 by 9 pi mp m0 bar, which is nearly equal to 10 to the power 33 gram, or it is nothing but the nearest value of the mass of the sun. Okay, right? So the formula here 9.61 is valid for high density or for r approaching towards 0. Hence it is valid for m nearly equal to m0, and our model will give a remarkable prediction that no white dwarf star can have a mass greater than m0, because otherwise 9.61 उपरे जो equation पाइतला will give an imaginary radius, right? तेणुकरी the physical reason underlying this result that if the mass is greater than a certain amount, the pressure coming from the Pauli exclusion principle is not sufficient to support the gas against the gravitational collapse. Okay, so the radius mass relationship of this white dwarf star according to the model has actually the form which is shown in the figure 9.6, this one. Okay, एठी देखो solid line जो रोचे. Okay, here the solid line indicates the region covered by the formula 9.52 and 9.61, and we have not been able to calculate alpha, so that the exact value of m0 cannot be obtained, and more refined consideration will give the result. Okay, अच्छा ये जो स्टार मार्क दूची एक्चुअली एटा एई जो जर्नाल रू एटा निया जायछि. सिमिलर ग्राफटे आमे जबे तीनटा जाको केस जो ऊपर देखिला ताकू नै कि आमे पुट करि परिबा बाय टेकिंग रेडियस, that is the solar radius, along the y axis and the mass along the x axis. ओके तो एठी देखो एक जो ग्राफटा खास करी तमर रिलेटिविस्टिक फॉर्मी पाई आछी आ एई जागा रे ही टच करूची मास को, याठू आकू बढ़ुनी. ओके हियर दिस वैल्यू is nothing but 1.4. okay, mass of the solar mass. okay, तेणु this will give you a result m0 to be equal to 1.4 times of the solar mass, and this is the Chandrasekhar limit. Okay, as Chandrasekhar's limit. Okay, this mass is known as the Chandrasekhar limit, and thus according to our model no star can become a white dwarf unless its mass is less than 1.4 times of your mass of the sun. Okay, and this conclusion has so far been verified by astronomical observations also. And if the mass of a star is greater than the Chandrasekhar limit, then it will eventually collapse under its own gravitational attraction. Okay, and when the density becomes so high that new interaction domains thus far are awakened, then a new regime will take over. For example, star could explode. Okay, এটা পুরা explosion ହେଇପାରିବ star ର, like that of your supernova. Okay, so up to this I have taken this theory of white dwarf star from one book along with the Chandrasekhar limit, that is, and now this I have taken from another book. Same ଜିନିଷ ଏଠି ବି ଦେଇଛି but ଟିକେ shortcut manner ରେ ଦେଇଛି. Okay, ଏଠି এই ବହିରେ graph କିନ୍ତୁ include କରିନି. Okay, you can see, right, same way ରେ ଏଠି ବାହାର କରୁଛି e0 ର value, ତାପରେ ଏଠି fx f जोटा हमर value थिला integration रे दुईटा value आस्थिला, गोटे non relativistic आ गोटे relativistic ପାଇଁ, then p0 को calculation करला हमें. Okay, then mass, then m bar ଆଉ r bar ର value, gravitational interaction को ଏବେ ଆମେ consider କଲା. ଏଇ ବହିରେ ବି same way ରେ ଏଟାକୁ ବୁଝାଉଛି, ଦୁଇଟାକୁ ଏବେ equate କରିବା, ଆଉ finally p0 ର value ବାହାର କରିକି m0 ର value ପାଇବା, which is around 1.4 times of your mass of the sun. Okay, so ଏଟା ହେଲା second book ରୁ. ତାପରେ ଆଉ ଗୋଟେ ବି book ଦେଇ ଦେଇଛି ମୁଁ ଏଠି, third book white dwarf ପାଇଁ. same way ରେ ଏଠି ଇଏ जो प्लॉटटा पकाउची हर्ट्सस्प्रंग आउ रसेल डायग्राम. सो ए बहिरे भी तुम देख सेम वे रे डेराइव करची, राइट. ओके, मास एम को बाहर करची, पुणी रेडियस को बाहर करची, तापर एम बार एंड आर बार, देन योर p0 कैलकुलेशन. ओके, m0 mass of the sun, which is actually 1.4 times of the mass of the sun, the Chandrasekhar limit. Okay, so I advise you to read accordingly from the PDF that I have given from 3 books. Okay, now nijo hisabre you can make your note accordingly. Okay,
Thank you.